Hey everybody, Mr. Mack here. Uh, I'm going to do some solutions with you guys here on 6.1 graphs of exponential functions. And we have several parts here that I want to accomplish. I want to get a graph, but I want to find domain, range, and range has no I in it. Okay. And find our asymptotes and plot at least 5 points. And let's get started. Let's jump in. So I got f of x equals 4 to the power of x. So, f of x is just function notation. It's the same as y. I could replace this with a y equals 4 to the x. And so let's first perhaps think about what good values would work for x. We want to find our anchor point, and that is when we substitute 0 for x here. And we know that any base number to the 0 power is going to be 1. So 4, if I substitute this in, f of 0 equals 4 to the 0, we get 1. Okay, so we've got 0, 1. That's our anchor point. Crosses the y-axis at 1. So from this, we should try several points on either side of the anchor point. So let's try 1 in here. So f of 1 would be 4 to the first power, which is 4. 4 to the first is 4. So 1, 4. And then, so that's 4. Put it there to save space. Let's try f of 2. That's 4 to the second, which is 16. So I'm putting in 2, and I get 16. I'm all the way up here. 3 is going to be off the graph. Let's go the other way. -1, f of -1. That would be 4 to the -1 power. So if I wanted to make this into a positive exponent, I have to put these 4 into the denominator. So that would be 1/4. So -1, 1/4. So this is a half here. So right here, that's a 1/4. Right about there. And then f of -2 is 4 to the -2. If I write that as a positive exponent, it's 1 over 4 squared, which is 1/16. So at -1, I'm really close to the x-axis here. And as we see, as we get more negative, it's just going to get closer and closer to 0. So that means that our asymptote here is going to be the x-axis. So this is our horizontal asymptote, and it is y equals 0. So now we can start putting together our graph here. Just try to fit in the curve. Okay. So what is our domain? Domain are all the x values. So we could see this is going to go increasingly to the -infinity, and this will go into our positive infinity. So our domain is going to be -infinity to infinity. And I used our parentheses here, not brackets. And our range looks like we're going from 0, not including 0, all the way to positive infinity. Okay, and I've got my 5 points right here. And 3 is going to be off. So 4 to the third is 4 times 4 times 4. And that would be 64, right? So that's way off. All right, that one's done. So in this one, by the way, our a value of 4 is greater than 1. And this next one, our a value is between 0 and 1. So it's going to affect the way our graph looks. So again, where is our anchor point going to be? It's going to be when x is 0. So f of 0 is 1/3 raised to the 0 power. Anything raised to the 0 power is 1. So 0, 1 is my anchor, and it's my y-intercept. We're going to put 1, 2, -1, -2. Let's try these points. So let's go f of 1 equals 1/3 raised to the first power is 1/3. So 1 over 1, and then 1/3 is about here. F of 2 is 1/3 to the second power. 1/3 to the second power is 1/9. So we can see we're getting smaller and smaller as the x values increase. Okay, so this is approaching 0 here for y. So we do -1. I get 1/3 to the -1 power. I can make this positive by taking the reciprocal here. So this would be 3 to the first, or just 3. So at -1, I'm at 3. At -2, 1/3 of -2, if I'm going to write this as a positive exponent, it'd be 3 to the second, or 9. So at -2, I'm at 9. And now I'll do my asymptote here. Y equals 0. And let's get my graph here. That's terrible. I did my best. It's a little bit harder to make these curves by hand, or using this tablet. And let's see, so our points. Okay, so my domain, all my x values are going to work. -infinity to positive infinity. My range is, again, it's the same as the last one, right? It's not going to hit 0 or negative, so it's going to be from 0 to positive infinity. And I've got my asymptote. All right, that one's done. You can see if I use another point here, if I use another -1, it's just going to be off the graph, and then another positive one here. 1/3 to the third, 1/3 to the -3rd power, or third power rather, is 1 over 27. So it's just increasingly getting smaller. All right, next one here, we've got a negative happening right here. So what's that going to do? Well, this negative is going to give us some sort of reflection. Okay? So We did 1/2 to the x already in the notes, I believe. So let's start off with 0 again for x to get our anchor point. And let's see what happens. So I got f of 0 equals negative 1/2 to the 0 power. So anything to the 0 is 1. But then we multiply through by a negative, so we get -1. So 0, -1. Okay, so instead of being 0, +1, we're at 0, -1. So instead of being above the x-axis, we're below the x-axis. Let's try 1. -1/2 to the first power. So 1/2 to the 1 is 1/2, and then we make it negative. So 1, and we're at -1/2 right here. Okay, over 1, down 1/2. So 2 -1/2 to the second power. So that 1/2 to the second power is 1/4. So I'm at -1/4. So I'm at 2 -1/4. Okay, so we're getting closer and closer to 0, and you can see here, no matter what I put in for x, it's never going to get to 0. It's just going to get closer and closer and closer to 0 from the negative side. Let's try -1 and then -2. So if I put -1 in, I get negative of a 1/2 to the -1. To make that a positive exponent, I take the reciprocal, so I get 2 to the first. 2 to the first power is 2, and make it negative. So this is going to be -1, -2, and -1, -2 right here. Okay, -2 -1/2 to the -2. In order to make this positive, take the reciprocal. 2 squared is 4, and then we multiply through by a negative, so we get -4 here. Let's put in -3. I'm going to add a point here. So f to the -3 equals -1/2 to the -3, which is -2 to the third power. I'm going to make that positive. 2 to the third is 8, and then multiply through by negative. So I get -8. So -3, -8 right here. I could fit that extra point in, so that's why I did it. Okay, and again we see our asymptote is still y equals 0. Let's get the graph. I missed this a little bit. It's okay. And our domain is going to be, again, from -infinity to infinity. But our range is a little bit different here. Our range is coming from the -infinity, and it approaches 0, but doesn't hit 0. So we'll do an open there. All right, that one's done. Okay, so now, number 4, I am changing the negatives. I'm basically moving this negative off of in front of this part of the function and putting it in the exponent. So what's that going to do to my graph? All right, so let's try, let's do 0 again. Let's see, I'll put 0 here. So f of 0, 1/2 to the -0 power. So negative 0 is 0, and 1/2 to the 0 is 1. So we got 0, 1. All right, so we're back up in the top half of the graph here. This is my anchor point. Let's try 1. 1/2 to the negative 1. Okay, so to make this a positive exponent, we take the reciprocal. 2 to the first is 2, so I've got 1, 2. Let's put 2 in. See, that's 4. 2, 4. And I guess I could have done 3 on this one. So if I put a 3 in, I should have moved my 0 up. So 3, if I put a 3 in for this, 1/2 to the negative 3, that would be 2 to the positive 3, or 8. Okay, negative 1. Is going to be 1/2 to the negative of a negative 1. So a negative of a negative 1 is just positive, so this is just going to be 1/2. So negative 1/2. And I hope you see what happens with the negative 2. It's going to be a quarter, right? A negative of a negative 2 becomes positive. 1/2 to the squared is a quarter. So negative 2, a quarter. Y asymptote again. Y equals 0. And see if I can fit this curve in here. That was my best one. And I forgot to fill out the rest of this chart. Okay, so negative 1, we got 1/2. Negative 2, we got a quarter. Domain, negative infinity to infinity. Range, okay, we're going from 0 to infinity. Okay, number 5. So 5 and 6, we're changing stuff, all right? We are adding or subtracting, for one, outside the function, and then one with the exponent. We're doing both, actually, on this one. All right, so, all right, let's see, what points do we want to use for this? Well, I want to get this base value raised to the 0 power. So x plus 3, what gives me a 0 in here? What gives me 0? A negative 3 for x, right? So I'm gonna put negative 3 here for my x, and I'm going to get f of negative 3 equals 1/3 to the negative 3 plus 3, and then I have minus 2 out here. So 1/3 to the 0 right here. That's what we get. Negative 3 plus 3 is 0. That's 1. So I end up getting 1 minus 2. This equals negative 1. So if I put negative 3 in for x, I'm at negative 1 on the y. All right, so I'm going down into below the x-axis here. All right, so let's try negative 4. we want points. So this is my anchor right here. And so I want to get points on either side of my anchor. So let's try -4. Just want to look at the equation as I plug it in. -4 plus 3 minus 2. So -4 plus 3 is -1. I want to make this a positive exponent, so I take the reciprocal. 3 minus 2 is 1. Okay, so -4, 1. Let's try -5. Okay, so -5 plus 3 is -2. I'm just going to skip that step. I just combined the -5 plus 3 is -2 minus 2. Take the reciprocal here. 3 to the second minus 2. 3 to the second is 9 minus 2. This is 7. -5, 7. I'm right there. Okay, we can see this is getting larger. Our y values are getting quickly larger. How about let's go the other side of the anchor point with -2 and then -1. I'm going to go right here. F of -2 is 1/3 to the -2 plus 3 and then minus 2. So -2 plus 3 is 3. 1/3 minus 2. All right, well that's -1 and 2/3, right? If I take 2 away from 1/3, it's -1 and 2/3. So -2, I'm at -1 and 2/3, I'm here. Okay, so that 1, and then that's 1/3, and then that's 2/3, and then that's 3/3. So boom, right there. All right, and then, so that's -1 and 2/3. And then F, running out of room, F of -1 is going to be equal to 1/3 raised to the second power here, right? -1 plus 3 is 2. Okay, and that's going to be 1/9 minus 2, which is -1 and 8/9. Okay, -1 and 8/9. So not quite -2, right? It's getting there. All right, so we can see that if we increase this, okay, so -1 and 8/9. Whoops. All right, so as x gets larger here, so if I put 0 in here, 0 to the third, 1 to the third power is 1/27 minus 2 is -1 and 26/27, right? So it's approaching -2. So that is without actually reaching -2. So this is our horizontal asymptote right here. Y equals -2. Now notice the -2 outside here, it's already telling us where the asymptote is. Well, did it tell us on these other ones before? It did, because there was nothing being added out here. We could have said +0 here for that one. And for this one right here, we could have said, +0. And 0 was y equals 0 was the asymptote. Same for that one. Okay, so if we add or subtract anything outside of our function here, that is going to be what our asymptote is. And we can now fit our curve in here. And the domain, again, is negative infinity to infinity. Our range, however, look where we're going from. Negative 2 to infinity. Okay. By the way, on this last one here, what did you notice about this graph? I forgot to go back and talk about this. If we should see that this graph is exactly the same as the one we did in the notes, which was 2 to the x. It's exactly the same. Why? Well, if I wanted to make this exponent here positive, we just take the reciprocal here of 1/2. And 2 to the x makes a positive exponent. And this is one of the first ones that we did. And it's exactly the same as this one. All right, let's take a look at this last one here, number 6. You want to make a prediction where the asymptote is going to be for number 6? Look at this +1 right here. Our horizontal asymptote is going to be y equals 1. It's going to be right here. And let's see, what gives me a 0 exponent here? 2 to the 0. What value for x do I need? I need a 2. So I'm going to start off with that point, my anchor point. I want to plug in 2. So I get 2 to the 2 minus 2 plus 1. Okay, 2 to the 0 is 1. 1 plus 1 is 2. So 2 is my first point. Let's try 3. And I want to talk about shifting here in a second too, because now that we've done 2 of these, maybe we can understand what happens when we add or subtract inside this exponent. So I got 2 to the 3 minus 2 plus 1. 3 minus 2 is 1. 2 to the first is 2 plus 1. This is 3. 3, 3. Two to the 4 minus 2 plus 1. 4 minus 2 is 2. 2 squared is 4 plus 1 is 5. So I'm at 4, 5 right there. No, I want to do 5 next. Okay, so we see 5 minus 2 is 3. This is going to be 2 cubed, right? I'm skipping the plug-in step there, but I hope you can see. 2 cubed is 8, plus 1 is 9. 5, 9. Let's get some negative ones in here. Two to the negative 1 minus 2 plus 1. That's negative 3. 2 to the negative 3 is 1/8. Sorry, 2 to the negative 3 is same as 1 over 2 to the third, because I'm making it positive. And that's 1/8 plus 1, which is 1 and 1/8. Let's make sure I'm doing my math right there. Yeah, 1 and 1/8. So I'm at, where are we here? Negative 1. Oh, okay. Negative 1, 1 and 1/8. I'm like over here. So I did negative 1. I meant to do positive 1. So let's do a positive one here. So that's 1 1/8. Now that's my bad, but that's okay. Let's do 1 in here. I'm staring at the screen. 2, and we're going to do let's see my function here. So we got 1 minus 2 plus 1. Okay, 1 minus 2 is negative 1. So that's going to be 1/2 to make that positive exponent plus 1. That's 1 1/2 or 1.5, right? So 1, 1 1/2, I'm right here. Okay, so if we did 0, that would be 2 to the negative 2 is 1/4 plus 1. That'd be 1 1/4 would be here. Okay, and fit the curve now. One thing I want you to notice here is that normally when we did our other problems here, when we weren't adding or subtracting inside our exponent, 0 was always going to be where our anchor point was for x. 0 right there. Same with this one, 0 was our anchor point right there. But the anchor point shifts when we add or subtract inside of the exponent. So when we added 3 in this one, so we shifted 3 over to the left here. So we went 1, 2, 3. Here is the anchor point, was at negative 3 on the x. Because this, when we add inside our function here, it's going to shift left. And then when we add or subtract outside the function, this shifts up and down. This one shifted down. So the x plus 3 shifted left 3, and then this shifted down. Or I could say vertical shift, and this is a horizontal shift. So this is a horizontal shift, and this is a vertical shift, 2 down. Same with number 6. We subtracted 2 here, so that shifts it to the right 2 units. Over here, that's our horizontal shift. Our vertical shift for this was up 1. There we go. I think that's good. And domain, negative infinity to infinity. I hope you see it's always the case. And then the range in this case is going to be 1 to infinity. All right, everybody, I hope that makes sense with how we graph these exponential functions. Maybe we'll do another video for these other practice problems. I don't want to be too much. And yep, see you next time.